Hello students, today we're going to talk about gas stoichiometry. So the new thing that we're going to talk about is at STP, 1 mole is equal to 22.4 liters. And remember STP, your temp is equal to 0 degrees Celsius and your pressure is 1 atm. And that's when you can use this. So very similar to before, I have these. The things that will change is the fact that you'll have that 22.4 liters in it, except for the one when we go liters to liters. That'll be very similar to your moles to moles where you use the coefficients in the balanced reaction. So we're going to calculate the volume. We want to know the volume of H2 produced when 5.6 grams of the NH3 decomposes. So this means that it's going from grams to liters because you have grams and you want to know the volume. So grams to liters is right here. So we're going to start with our given grams of A. So we had 5.6 grams of NH3. Then we need to put the periodic table grams of A on the bottom, and I forgot to get a periodic table ready. Let's see. Maybe it'll show up right away. Nope. So there we go. So we had hydrogen in there, that's 1.01, and nitrogen, which is 14.01. So 1 nitrogen plus 3 hydrogens, that would equal 17.04 grams. So that 17.04 grams goes on the bottom. And on top goes your 1 mole of A, and that is your ammonia. Because this is your A, this is your B, this was NH3, this is going to be your H2. Now we're going to put the moles from the balanced equation. So moles of NH3 and our moles balanced equation is 2. On top, we've got moles of B, which is going to be our H2. And we've got 3 moles on top. Lastly, we've got our 1 mole of B, which is your H2. And we want to go do the 22.4 liters of your H2. And then we want to multiply everything on top. So you'll take 5.6 times 3 times 22.4, divide by 17.04, and divide again by 2. And I got 11 liters of H2. Okay. How many grams of water are produced when we have 4.6 liters of methane? Okay, so we are going to go from liters, because that's what we have, to grams. So this is our A, this is our B, and our liters are of methane. Methane is CH4. And grams of water, so water will be our B. So liters to grams, so that means we're going to use this right here. So given liters of A, we had 4.6 liters of methane. On the bottom then will be our 22.4 liters of methane. And then on top, we'll have 1 mole of CH4, 1 mole of that A. Then on the bottom will be, from the balanced equation, moles of your CH4. Well, in the balanced equation, we only have 1. Then we put moles of B on top from your balanced equation. Our B is your water. And in the balanced equation, we have 2 of them. Then on the bottom will be our 1 mole of B, which is your water again. On top is going to be your periodic table mass of your water. So if we go to that periodic table, hydrogen again is 1.01, and now we have also oxygen, which is 16. So we have 1 oxygen plus 2 hydrogens times the 1.01, that equals 18.02. So this will be 18.02 grams of water. So multiply everything on top, 4.6 times 2 times 18.02, and divide by your 22.4. And I get 7.4 grams of that water. Okay. Last problem. Calculate the volume of NH3 produced when 2.4 liters of H2 is produced at STP. So we have been given liters, and we want to know volume, which is also liters. This is our A, this is our B. We were given liters of hydrogen, so hydrogen, and our B will be your NH3. So if you are going up, we're going liters to liters. So we're going to start with our given liters of A. So I was given 2.4 liters. 2.4 liters of H2 is our A. On the bottom, we're going to use liters of A, and we're going to get that number from the balanced equation. So we have liters of hydrogen, and in the balanced equation, we have 3 of them. Then on top, we're going to do liters of B, and also from the balanced equation. So liters of B, which is your NH3. And we have 2 of those. Then multiply everything on top and divide by everything on the bottom. So 2.4 times 2 divided by 3. Get 1.6 liters of ammonia.